The article called The Engineering Student Pipeline, published by the chair of that task force, J. Ray Bowen, argues that American technological leadership is being challenged by developed nations, both in Western Europe and the Orient. This is basically articulating the new image of competitiveness. Look out. We have a new threat from out there, beginning with Japan, but also in Western Europe and across the Pacific Rim. There's a fear in the United States. This article argued that there was good reason to believe that our industrial vitality will require an increasing engineering workforce in order to maintain competitiveness as the technological complexity of its products increases. In other words, if the United States is somehow falling behind because we're not producing up to speed with others, and we haven't focused on the quality of manufacturing to the extent others have, then clearly in order to increase our productivity, in order to increase our national competitiveness, we're going to need to increase the engineering workforce. So we start to focus on the size and composition of the workforce. Now behind this report lay a series of studies at the National Research Council, which organized, which mapped out the demographics of life in engineering education and then subsequent practice. And it was this group that originated the image and concept of the engineering pipeline. The pipeline shaped, and when it's presented visually, shaped actually as something of an hourglass, with the top, a champagne glass, not an hourglass. A champagne glass that is wide at the top and narrow at the bottom. The champagne glass indicating at the top the entry point, say kindergarten, where the possible number of engineers is quite large. But as we move through time, through elementary school, junior high, high school, into college, the number of potential engineers gets smaller and smaller and smaller and smaller until finally we get to a very narrow pipeline down at the bottom. And along the way, people drop out. So the pipeline image created an emphasis on so-called links. The modeling of the education system for the purpose of quantitatively estimating the flow of qualified students through the system led then to the characterization of this system as the so-called engineering pipeline. Now, the analyses of flows of engineering through this pipeline called attention to a big shift. The shift involved a decline in the future production, likely a decline in the future production of engineers. From the 70s to the mid-1980s, the number of engineers in this country was increasing. Indeed, the annual rate of production of bachelor's degrees doubled in the United States. And this arguably could be attributed to an economy that was expanding rapidly. There were lots of career opportunities for engineering students. But by the mid-1980s, the total enrollment in engineering had peaked and was beginning a decline. And this parallels a general decline in the total pool of 18 to 22-year-old students out there. Now, the overall enrollments in colleges was not declining, in part because non-traditional students were making their way into higher education. The older students who had gone to do something else and then returned to school. But such students rarely find their way into engineering. Students who go into engineering generally proceed directly, without interruption, from high school into college. And indeed, this is what engineering education wants. Engineering education differs significantly from education in law and medicine, let's say, which presuppose mature adults who hold bachelor's degrees in one field or another. Engineering specifically wants the high school graduate, in a way the blank slate, who can be trained in a thoroughgoing engineering fashion. By the mid-1980s, 3/4 of the degrees awarded in the United States annually were awarded to white males. Now, so how do we address this problem with the number of 18 to 22-year-olds going down, 3/4 of the degrees annually going to white males? Groups found themselves turning to other possible demographic categories and argued that greater participation on the part of women and minorities was one way of addressing this numerical problem in the United States. Well, what else was going on demographically in engineering education at the time? What about the faculty? Nearly half of the doctoral degrees awarded in engineering in the United States were awarded to non-US born students. So the engineering faculties were changing. The reports, in this case the task force report from the Engineering Dean's Council, argued that we need some more effective intervention programs.